Have you ever spent hours meticulously designing a storyboard only to find the generated video looks nothing like what you envisioned? Are you staying up all night just to fix a single bad clip, playing a seemingly endless gacha game with infinite rerolls until you finally get that one usable shot? Sometimes you even burn through an entire month's worth of credits just trying to piece together a single scene. But now, with Google Flow's newly added character library, we can finally escape this absolute nightmare of consistency issues. What exactly is this feature, and how do you use it to unlock 100% of its potential? Today, for the first time ever, I'm going to reveal the true design intent in core workflow known only to developers, something even the official Google help documentation fails to explain properly.
Most people think consistency breaks are just about a character's face changing or glitching between different scenes, and to fix this, they just keep messing around with the storyboard feature. But in a real production environment, consistency failure is never that simple. As you can see on the screen right now, a cinematic sequence where the camera pushes in from a distant wide shot to a tight close-up was an area that could never be solved with standard storyboards or basic prompting. The face literally changed into a completely different person every single time. However, by leveraging the newly updated character library in Flow, you can now flawlessly execute this complex cinematic zoom-in shot, even with just a natural language prompt. Let's dive right into the ultimate character building workflow that will save your credits and succeed on the very first try.
Step 1 is creating your character assets right inside Google Flow. Here is a critical rule. Always start with a completely fresh, brand new project. Do not try to build a new character inside a project you're already working on. Why? Because any existing video data or prompt history left on your current timeline can easily cause cross-contamination, messing up your character's baseline metadata. To ensure a flawless character setup, always start with a clean slate.
Next, you must set your canvas size strictly to a 9:16 aspect ratio. Right now, this is a non-negotiable rule. The Google Flow Core development team has hard-coded the system to optimize character consistency specifically for the 9:16 vertical format. While the structural limitation might change or be expanded in future updates, as of right now, keeping it at 9:16 is the only way to guarantee a perfect character build without breaking the system. So make sure you lock it into vertical mode.
When it comes to writing your prompt, keep your descriptors as clean and concise as possible. Don't overcomplicate it. You want to focus purely on the core features. For example, instead of a long story, just write a full body shot of an elegant and graceful 30-year-old Korean woman wearing casual clothes. Keep it sharp and let the AI do the heavy lifting. Generate a batch of 4 images and pick the best one. If none of them hit the mark, don't hesitate to re-roll until you get the perfect visual profile for your character. Now, for those of you who work with JSON prompts, here is a golden nugget. Choose an outfit where the top and bottom are clearly separated, rather than a single-piece dress. Why? Because when Gemini generates the JSON configuration, this separation allows it to break down the wardrobe metadata into discrete parameters. It gives you highly granular control over the top and bottom individually, making your asset control infinitely more precise. Once you've locked in your favorite image, export it by downloading it to your PC. Now, let's step out of Flow for a moment and head over to Gemini. We're going to use Gemini as a metadata parser. Upload your downloaded image and give it this exact prompt. Analyze the face, hair, and clothing in this uploaded image and generate a structured JSON character configuration code. And just like that, our JSON character script is ready. If you're an advanced creator who drives video generation entirely through programming methods like JSON prompts, you can take this code straight into your production workflow.
However, since many of you prefer using natural language prompts to direct your scenes, I'm going to show you how to reverse engineer this JSON payload back into a standard description block. Simply paste the generated JSON code back into the Gemini prompt box and issue this instruction. Convert this JSON character configuration into a natural language prompt optimized for Google Flow. Excellent. Now we have our clean natural language character profile.
Let's grab this generated text block and copy it over to a document editor like MS Word, where we can fine-tune a few core features before deploying it.
Always remember, your characters must be managed as a tied pair, consisting of both the master image and its matching configuration code. Within this character dataset, you need to clearly separate the key parameters: identity, features, clothing, and props. While you won't have to write this syntax from scratch, since Gemini handles most of the coding heavy lifting, you have to be incredibly careful here. Gemini will often automatically bake accidental items into the code, like a handbag, a coffee cup, or a book that happened to be in the reference photo. It might even latch onto a temporary posture. If you deploy this code without catching those errors, your character will be permanently stuck holding that exact cup in every single scene of your movie. That's why right now, at this stage, we must thoroughly audit our configuration file. We need to preserve the core essential elements, scour the script for any unintended anomalies, and trim the fat down to a perfectly clean default baseline. Once this master dataset is completely optimized, lock it down. This becomes your absolute source of truth, and it must be stored safely without any further unauthorized modifications.
Once you've thoroughly audited your configuration block, copy only the identity, features, and hair segments and head back over to Flow. We are now entering the most critical phase of the entire process, building the core facial identity. Because this sets the foundation for your character's DNA, every single parameter must be executed with absolute precision. First, change your canvas size in the Flow prompt settings to a 1:1 square ratio. This is a non-negotiable step. It must be a 1:1 square. Now, paste your clean identity, features, and hair data straight into the prompt box. Right at the end of that string, append the following camera command to trigger the generation. Close up on face. Once the generation is complete, review the batch and select the image that best captures your character's unique personality. Here is a strict requirement. You must select an image where the character is looking directly at the camera in a straight-on, frontal view. If none of them fit the bill, keep re-rolling until you get the perfect look. When you found the one, delete all the other discarded variants, leaving only your chosen master shot on the canvas. Now, click into the Image Edit panel. First, wipe out the entire background to isolate the subject. Next, strip away any clothing or accessories visible around the neckline. Pay extremely close attention here. Double-check the hair for hidden earrings or studs. Every single piece of jewelry or body attachment must be completely purged. We need nothing but pure, unadulterated facial data.
Now, we are finally ready to officially register our asset into the character library. Click on the character library icon on the left side of your screen to open the management panel. Below the prompt box, you'll see two utility options. Click on Add from Project. Select the clean, isolated facial image we just optimized. As soon as the asset loads, the interface will switch to the character profile configuration screen. On the left, you'll spot the character info description box. Now, a quick warning here. The UI labels this field as optional, suggesting you can leave it blank if you want. Ignore that completely. This isn't a trivial option. It is the crucial anchor that defines your character's entire visual identity. Go ahead and paste the exact identity, features, and hair code blocks we refined earlier straight into this box. Right above it, the untitled character field is another absolute must. This is where you declare your character's unique handler, so input your chosen character ID right here. Leave all other parameters, like voice, completely untouched for now. Head over to the top right corner, hit the Done button, and our baseline character registration is complete.
We are now moving on to the next phase, building the character's body frame. Go ahead and switch your Flow project settings back to a 9:16 aspect ratio. I cannot stress this enough. Make absolutely sure it is set to 9:16. Now, let's open up our text editor where we stored the master configuration code. This time, highlight and copy everything except the identity, features, and air blocks. We want the rest of the entire clothing and body dataset. Head back to the Flow prompt interface and paste that string right in. Next, move your cursor to the very first line of the prompt box. Type in base_ID:, and then press the @ symbol. This will pull up the Asset dialog box. Navigate to the Character Asset tab on the left, locate the unique character ID we registered in the previous step, and select it. Your syntax should look exactly like this: base_ID:, @ your character ID. Now, scroll all the way down to the final line of your prompt block and append the following background control override: background: no background. Hit Generate to execute the build. Once the batch is ready, scan the variants, lock in the best-looking image, and discard the rest from your canvas.
We are now ready for the final piece of the puzzle, locking in the body asset. Click on the Character Library icon on the left panel to jump back into the Asset Management screen. Select your character profile, and this time, click on the Body Build Add Extra Views button. Then choose Add from Project. From the Asset dialog box, select the 9:16 full body master image we just created. Once the asset loads into the slot, navigate to the top right corner of the interface and click the View History button. Take a close look at the metadata trail. If you see your syntax linked perfectly, like this, base_ID @ your character ID, then congratulations, you've nailed it. Your character's biological DNA and physical wardrobe assets are now flawlessly unified. Hit the Done button to save changes, and your master 9:16 cinematic character is officially ready for action.
Now, it's finally time for the ultimate test, seeing our fully unified character in action. We are going to execute a complex cinematic sequence that pushes all the way in from a distant wide shot to a tight facial close-up, a transition that was completely impossible with basic natural language prompting until now. First, let's head over to the settings and change the canvas size to 16:9 widescreen. Of course, if you're focusing on vertical content, you can absolutely keep it at 9:16. Now, let's establish the scene using a standard description setup to generate our base plate. EXT, beautiful Korean garden, day, long shot. In the distance, @ your character ID is standing, facing directly toward the camera. Once the initial frame is generated, grab that asset and drag and drop it straight into the reference prompt window. With our reference image locked in, move down to the control prompt box and inject this precise metadata and camera orchestration block. Metadata @ your character ID. The woman in the center of <asset 01 < is @ your character ID. Her face must match the official @ your character ID profile with absolute consistency. Camera, Dolly-In and close-up on @ your character ID's face. Executing a cinematic zoom-in from a distant wide shot to a tight close-up used to be an absolute dead end for standard natural language prompts.
While it was technically achievable through complex programming methods like JSON prompting, it required a brutal amount of manual labor, forcing you to hardcode the master image assets and complex syntax directly into every single prompt block just to maintain basic identity. All of that heavy lifting has entirely been consolidated into a single @ symbol. This is the massive, game-changing breakthrough we have all been waiting for.
That said, there is still a noticeable rendering quality gap between the Veo and Omni engines, meaning you'll need to run some side-by-side test renders depending on your project. While expectations were incredibly high, it is a bit disappointing that this system currently reaches its full, flawless potential only within Omni's frame mode. However, given how fast things move, this structural limitation might already be patched and upgraded by the time you're watching this video. Today we did a deep dive into Google Flow's brand new character library, breaking down the exact blueprint to optimize your workflow and protect your credits. In the next episode, we're going to put both Veo and Omni through a brutal stress test across various environments, doing a side-by-side quality comparison while unlocking advanced directorship techniques to squeeze every bit of power out of this library.